Hi there. My name is Danielle Townsend, and today I'm going to do a video demo for you about the equation of a circle. We come across this standard both in geometry and Algebra 2. It's included in the conic section, and also you come across it again in calculus and pre-calculus a little bit. So this is a topic that continues to come up in standards throughout high school math. So let's get started today. Today we're going to talk about the circle that you see behind me and how we can graph it on the coordinate plane and what that means in terms of its equation. Because everything that we can graph on a flat surface like this on a 2D plane, we can also come up with an equation for that graph. Just like a straight line, we typically graph, and we would give the equation y equals mx plus b. In that form, that would be the slope-intercept form. We could also write that in standard form as ax plus by equals c. Quadratics have standard form. They also have vertex form. And that goes for cubics. That goes for really any type of equation that we are graphing. Because when we are graphing something, we also want to be able to relay it to in written form. So if it's not graphed, how can we write it in a form other than picture form in case we're not able to write it like this? So here behind me, you'll see that I have a Cartesian plane. This is my y-axis. Here's my x-axis. And on this plane, I have a circle. So in my circle, there's a center right there. And my center, as in all conics, is always labeled as HK. If you can't see that, I can probably get zoomed in a little bit better, but we'll write down here, center equals HK. This is true for all conics. This is true for parabolas. This is true for ellipses. Anytime we have a conic, we're going to label the center HK. Why not XY? Well, because we are going to choose a point that's on the circle. If you think about the center really isn't included when we're thinking about what a circle is. When you draw a circle, you don't draw a circle and then the center. You just draw the outside of the circle. So when we're thinking about the equation of the circle, we're really thinking about the outside of it. And so if we were to pick a point, we could pick any single point on here that we want. I'm going to choose this red point right there. That's a point on my circle. I could have chosen any point along that circle because when I'm thinking about points along points on my circle, they're all equally distant from the center. I can make a line from here to here. That's the same distance as any point on the circle is from the center. That's a radius. There's an infinite amount of radii on that circle. So really, if I'm thinking about the equation of the circle, it's really asking how far away are all of these points from the center. If I can describe that in an equation, then that's how I can write this down and I can communicate this to someone else. So let's think about how we can describe how this point is related to this point right here in the center. And the first thing I think about, well, is if I want to describe how far this is away, that's a distance. And when I'm thinking about distances, and I'm thinking about a circle, I can always go back to the Pythagorean theorem. And the Pythagorean theorem means that I can make a right triangle. And the Pythagorean theorem comes up over and over and over again in math because, excuse me, I can make a right triangle so many times. You can make one down here, or I'm going to make mine over here. That right there, and I'll choose red. There to there. That makes a right triangle now with the center and that point that I have. Now, because The way that I figure out this distance, this is just the hypotenuse of that right triangle, is it's going to be the purple squared plus the red squared equals the green squared. Or we know that as a squared plus b squared equals c squared. That's our basic quadratic formula, and that's where we get the distance formula from. But in terms of a circle, how can we better describe that? Well, let's start with our point along the circle. That point we would call, like any point anywhere in a coordinate plane, x, y. We can always describe a point as a coordinate of x, y. How far over on the x-axis did I go, and how far on the y-axis did I go, either positive or negative? Well, if this is x, y, let's think about what this distance is right here. I'm thinking that this purple line right here is going to be what all of x was. So if this whole thing is x from here to here, we know that's x because I got to x right there. If I know this whole thing is x, but right here from here to here, so that's all x, but from here to here is h, then this portion of the line must be x minus h. So for b in here, I can call this x minus h instead of b, because now we're getting a little more complex with how we're describing these. Now let's talk about the red line, the red portion. Well, if I know that this whole part in here is y, so this whole portion from here down is y, but I used up some of that with k, from here to here is k, well then what's left there? That would be y minus k. And that leaves us with what c squared would be. But c is now, if you think about it, c is just a radius. So we have r squared. Now if we take this and we put it in order, what comes first? X or y? We're going to say y comes first. Or sorry, no, in the alphabet x comes first, I apologize. So we have x minus h squared plus y minus k squared equals r squared. And that's the general equation of any circle. We can fill it in separately or differently depending on which circle we have. If we have a circle that has a center at 4, 2, then h becomes 4, k becomes 2. If our radius is 5, then this would be 25. If our radius was 7, then this would be 49 because we're taking our r and we're squaring it. This is just a squared plus b squared equals c squared. Because when we're thinking about a circle, we're thinking about the distance from the center. And remember, the distance formula and the Pythagorean theorem, they're the same thing. So a lot of times in math, we're thinking about how can we make a right triangle and how can I use the Pythagorean theorem to differently explain what I'm doing here or to make this work. The Pythagorean theorem is our friend in so many ways. Thank you.